Hi everybody, this is CR number 13. We are going to be doing a helper video for the extended response. It says you purchase movie passes online at Fandango for $12 each plus a $2 printing fee. You have a coupon for 50 cents off your fee. If you have $34 to spend, how many tickets can you buy? All right, the first thing we always do is we write our let statement. So let me just make this a little bit bigger so everybody can see it. There we go. And I'm going to go ahead and use x for my variable. So let x equal, and we always look to the last sentence of the word problem because that usually tells us exactly what we're looking for. And in this situation, the last sentence says how many tickets can you buy? So we are actually looking for the number of tickets. So let x equal the number of tickets. Now the first thing that I do is I looked at the numbers that I'm given. I'm given a $12 here. Let me just switch that. I'm given a $2 printing fee here, and I have a 50-cent off key here or amount here for a coupon. And I have a total of $34 to spend. So the first thing I do is I try to figure out what number describes the variable. The variable represents the number of tickets. So which one of these numbers, the 12, the $2, 50 cents, or the $34 represents or describes the number of tickets? I'm hoping that you're realizing it's $12 because it says here that I'm purchasing movie passes at Fandango for $12 each. That tells me how much each ticket is, so it's the unit rate, and that always matches my variable. So I have 12x, which means $12 times the number of tickets that I buy. I also have to pay a $2 printing fee. So I'm going to tack on or add that $2 printing fee. But I'm very lucky today because I have a 50-cent off coupon. So from that $2, I am then going to subtract that 50 cents for that coupon. And that should equal the total amount that I'm spending, which is $34. Okay, so the first thing I have to do is look at the left side of my equal sign. I notice I have two numbers that are constants, which means they don't have variables. I go ahead, I draw my ladder. I combine my constants, which is 2 minus 50 cents, which is $1.50. And then I go ahead and bring down my 12x, my plus because it remains positive, and my equals 34 because that did not change. I then need to get my variable by itself, so I look to see if anything's being added or subtracted from the variable, and I notice that the $1.50 is being added. So I need to do the opposite, which is subtracting $1.50. Anything I do to one side, I do to the other. And notice the way I'm lining this up. Because it's a decimal, I have to realize that the cents have to line up with the cents, and the dollars have to line up with the dollars. I'm going to go up here so I have more room. This side cancels out or zeroes out. I'm left with 12x on the left side. And that equals 34 minus $1.50 is $32.50. And remember, you can always use your calculator if needed. I then realize that the coefficient is being multiplied by the variable x. The opposite of multiplication is division, and the reason why I'm dividing is to get the x by itself. So I'm going to go ahead and divide both sides by 12. 12 divided by 12 is a fancy form of 1, which is what I want because don't forget that helps me to get the x by itself. I am then going to take $32.50 and divide that by 12. I highly recommend that you use a calculator. So I get x is equal to 2.7 approximately. It does keep going on and on and on the decimal. But once again, I have to come back to my let statement and my last sentence. I'm going to highlight that in a different color, which is how many tickets can I buy? Well, I can't buy 0.7 of a ticket. So because my answer is 2.7, the greatest amount of tickets I can buy with the amount of money I have is 2 tickets. And the reason why I know to label it with tickets is because my let statement tells me. My let statement always tells me how to label my answer, which is number of tickets. All right, good luck with that one.